me start the recording. Okay. Okay, guys, welcome to this first class of Snowflake, and I welcome you all. So this will be a weekend class with 2 hours of learning. We will have a 10 minutes break in between, and we'll just regather again after the break. And so my style of teaching is that you can always stop in between and ask your questions. I will not leave them for the end. For the end also, if you have any questions, feel free to ask, even if the session goes beyond 2 hours. I don't mind. Okay, and yes, so feel free to stop me in between, and we'll learn together. And I'll make sure that we try to cover all the important topics of Snowflake, and also we try to learn from the conceptual level. So, learning from the code level or from the very basics makes your advanced learning, easier. So that is how the strategy of learning will be. And to introduce myself, I am Abdullah Siddiqui. I have 14 plus years of experience in the IT industry, and it has been all in the data engineering side. So I have been working in Oracle databases for quite a few years. Then I have rich experience in PL SQL. From the past 1.5 years, I've been working on Snowflake as well. Then I have experience on ATL tool like Matillion. Then I have worked on shell scripting as well. And of late, I did some POCs in Python as well. Okay, so that is my brief introduction. And so, yeah, so as you all know, we have gathered here for the Snowflake training here. And the agenda for today would be, we'll first see what a data warehouse is. Okay, then we'll see on-premise versus cloud. Then we'll look at a few AWS services. Then we'll get into the history of Snowflake, how it started, who started it. Then the Snowflake architecture, how it works under the hood. Then, if time permits, I think till the topic of architecture, I think that will consume our 2 hours. If not, we'll take it forward from there for the rest of the topics. Okay. So I want to take it very nice and slow. I want to make sure that you understand the topics that we are covering each day. Okay. So you don't have to worry that this is just a 8 weeks and 10 weeks course and we have to wrap it up. Don't worry on that aspect. Even if it means to extend beyond a little more, maybe 2 weeks more, we'll do that. Okay. Fine, guys. So let's start with the class today. Anybody wants to say anything before the class starts? Okay. So I would request you all to please go on mute. And if anybody of you has any question, please feel free to unmute yourself and ask a question. Okay. Okay. Thank you, guys. Okay. So let's start. So guys, as you know that today's world, they call data as the new oil. As per the definition from the experts, they are calling information as the new oil, and the analytics part of that, they're calling it as the combustion engine. Okay. So like how oil, is a very important energy, or I mean, it's a source for driving the economy. It's used everywhere in all aspects of life, whether it's transportation, cooking, generating electricity, etc. So, but oil in its crude form, it's not of any use as such, right? It has to go through the process of refinement, right? So that is where the analytics come into picture. So when your data is in the crude form, it's still not become an information, right? To derive information out of it, there has to be an analytics associated to that data, which will perform the required analysis on it and derive some meaningful information out of it. So they're calling data as the new oil and the analytics part as the new combustion engine, which basically refines your oil. Okay. So, but oil will definitely, the reserves will definitely perish one day. Okay. but the data which is growing in today's world is virtually infinite, isn't it? So the the daily surfing of the internet, when you guys do surfing on the internet for maybe for online shopping, or maybe for looking at some web pages, or maybe watching videos, movies, each and every time you are basically you are basically consuming data, and you are also generating data, and that is virtually infinite, guys. Okay, so so data is a very important aspect as far as business is concerned today. So, why is it important, and what are, so basically business wants to derive insights out of that data. For example, I'll take one use case to begin with. Say we have an online retail shop, or even they have physical centers available wherever possible, and also online mechanism available for the users. So what are the questions at the end of the day my business team has to answer, so that my business can perform well, and it can also have an edge over my competitors, right? So maybe some basic questions, like if I have multiple stores, I would say, okay, which store is performing best in sales? That could be one question. Then which store is not performing up to the mark? Who are our premium customers? Which region has most sales? Okay. So maybe if we are an online, e-commerce website as well, and whenever a customer requests or buys a product from our website, so there'll be a courier partner associated with our business, who will deliver the products to that particular customer. So which courier partner is performing best for us? We need to look at that as well, isn't it? Which region is likely to have maximum traffic during holiday seasons? Okay, so as you know, in India, India is a very potential consumer base, isn't it? So we have so many holidays, whether it is Eid, Diwali, Dasera, so many, and even each state has their own, festivals which are celebrated on a grand level. Like Durga Puja in Calcutta, Onam in the south, and all that, right? So it's having a huge potential, and during those festivities, people like to buy stuff. So, accordingly, so how does this business insight come from? How do we answer all this? Obviously, there has to be some data based on which I will come to an insight. Okay, this is the particular store I think is performing well, this is the store which is not performing well. And why it is not performing well, that also I can understand from the data. So this is a brief, way to tell you like why data is so important. Okay, so let's understand it from a diagram level. Okay, so guys, I am going to take an example of a retail uh, business. Okay, maybe Amazon, Flipkart, kind of. Although they are online, let's say maybe someone like Reliance, which has customers even at the physical level, or in the malls as well, and also on their websites you can go and buy. There's the VJ sales also, if you have heard of it. They provide you centers physically as well as online facilities. Right. So consider this, you know, so there could be various, data sources. So this is your POS, which is nothing but point of sale. So point of sale means nothing but the where the buying is happening. Okay, so there would be customers, you would be going to a retail shop and you will be buying some stuff, and there'll be transactions happening there, right? So this would be one particular, data source for me. Here I am going to record all your transactions. So say you buy a mobile, or you buy some wallets, or maybe some iPads or iPhones, like that. And also these, my retail shop or retail business can be spread across the world, in various countries. So my data would be coming from, say, somewhere from the UK stores, from Indian stores, from Australian stores, from US stores, and they're coming into my database here, the store database. I am gathering all this data from here, from the different sources that I have. So one is your point of sale. Here, all the transactions related to your shopping is happening. Then I have insurance data as well. Okay, so you sometimes also, if you want, you can take insurance on the project, on the product that you're buying, right? so that you have some minimum guarantee or warranty, even if it breaks or even if it gets stolen during the delivery. So you will have some insurance available for it. So that data I will have. Then there'll be some surveys, where I will ask the customers, how was your experience? Are you likely to recommend it to other friends and family members? All those kind of survey questions that you normally get to give the feedback of the customer representative who served you. How was your experience here? What would you like us to improve and all that kind of data. So this is nothing but data, right? All this is your data sources coming from wide variety of data sources and coming from different regions. So such kind of data, right? When you are doing transactions, when you are gathering information, this is your online transactions, or if you want to call it just maybe transactions. So such data, which is just your transaction, always is stored in a system or in a database called online transaction processing. So this data you are not going to do any analysis on. You are just going to do the transaction. You come here, buy a mobile, your transaction gets recorded in this online transaction processing. That's it. You won't do anything apart from that. So basically you're recording the transaction, okay, from various sources, from various other sources. So that is your online transaction process, which is happening in the real time. Okay. So you can understand if you have millions of transactions and lakhs of transactions happening on a daily basis, provided you are a famous online retailer like Amazon or Flipkart all over the world. So you will understand that there'll be so much of reading and writing happening on this particular online transaction processing database, and hence it becomes mission critical. Which, because if my hardware here fails or something happens, my online transaction processing will stop, and that will impact my business on a very high level. Correct. So this is my very heavy on read and write cases. It's a very read and write heavy intensive database. That is why it is mission critical. So I will keep on just recording my transactions here. I will not be doing any insights. Why? So because, say, let's understand. See, these are my transactions. Okay. These are my transactions which I have been recording. So what is this typical record looks like? So this is my product selling. Okay. Say this particular customer, Kaushik, he bought mobile phone, and I allocated this Superman Travels courier to provide him the delivery. And he bought number of items he bought is 1, and price was 50K and so on. So these are my transactions. If my hardware goes down, I will not be able to make my selling. It will impact my business. So this here, if I have say Kaushik, who is my say loyal customer, and he is doing transactions in a year, maybe say some 100 transactions. And if I want to see how much total he has, done shopping on my retail shop, I will have to do an aggregation, right? So I will see, okay, Kaushik, I will group by Kaushik, my customer, and see, okay, how much total sales I was able to do against Kaushik. If I do it on the same database here, which is my online transaction processing, that will again take a lot of processing power and consume my compute resources here, right? So that will also hinder my online transactions here. So this is not used for analysis purpose. Okay, so that is why it is called as online transaction processing. So here you don't do any kind of complex queries. This is just to facilitate your business process. That's it. Okay, so whenever you want to ask, somebody asks what is OLTP, you can simply tell them that it is an online transaction processing system, which is read and write intensive. It is only meant for facilitating your business process. Record your transactions, and that's it. Do nothing. Cool. So here I have recorded a lot of transactions. Okay, this is my product related sale, point of sale, you can say. Then this is my insurance data where, some customers bought insurance against the product, they chose. Now, to answer these questions, which we just looked at some time back, these questions, obviously I will have to do some analysis on my transactions, the data that is coming in as far as sales are concerned, or the insurance bought by my customers and all. I need to do analysis on this data only. This data only I have to do. But as I said, on the online transaction processing database, I cannot do this because it will hinder my business process. My online transaction processing database is not meant for that. Sorry. Yeah. Hello. Yeah. Sorry. Somebody has a question.
That's a meeting.
I'm sorry. I'm not able to hear you. Okay. Okay. You can come back whenever you're ready. I mean, it's fine. I'm not able to hear you. Okay. Continuing. So what we do is, or what the technical architects who design the databases, they basically say, okay, let's move all this data to another system, okay, some other database or other storage, where we will keep all this data and do analysis there, so the online processing does not get hindered or hampered. Okay, because there when we do the analysis, it will be firing in a lot of queries, right? We will do a lot of aggregations, we'll be doing a lot of processing on the data to gather the insights. So this will become a very processing heavy database. But we don't want to do it on the online transaction processing because that will hinder the daily business process. So what they say is, okay, let's move all these data to another database and we will do our analysis there. And that is nothing but your OL, sorry, this should be OLAP, not OLTP, I'm sorry. So they'll say, okay, let's move it to another database system, which will be online analytical processing. So I will be just doing my analysis here. That's all. And this is nothing but the data warehouse. Okay. So here the transactions are happening and here everything is going to my OLAP system, which is nothing but my data warehouse. And it will do all the analysis to gather insights out of my data to create meaningful information out of it. That is what the data warehouse is supposed to be. Okay. And so, and also this system will record all the historical records you will have, because obviously if you want to do some analysis on particular customer, you need to know the purchasing history of that customer, right? Okay, so what was the kind of purchasing history? So if you look at an example here, so there's this customer called Priya. Okay, she has been returning the product each time she has bought it. So she bought a bag and she returned it, return status. This is your return status. And what is the reason? She said she did not like it. Then she bought another product. She said she did not like it. And similarly, there was as per the purchasing history of this particular customer, there has been some issues from the customer side itself. The customer doesn't seem to be serious, or there's no point concentrating on such customers. Okay, so we know from the history of the purchasing history. So that history will always be stored in your OLAP. Here, always the latest transactions will be stored. Okay. So some of the examples of your online transaction processing is your book my show, okay, where you are buying tickets. Then there could be the ATM, when you go to ATM and you want to take out receipts. I want to know what is your balance amount. You want to withdraw something from there. So that is all transaction based. You are trying to do transactions there. Okay, so those kind of systems, your railway bookings, your ICRTC system, website, so that's all your transaction systems. Okay, so we need to know history of the data before you do the analysis. So which will come from the purchasing history in case of an online retail. So, but do we send this data from OLTP to OLAP as it is? No. in between, we have to do a few transformations. Okay. For example, what I will do is, so say Kaushik. So I want to, do aggregation. When I do analysis, I want to do the aggregation. Okay, so what was the total sales of Kaushik in this month? So I will group by the month for Kaushik. I will, uh, you know, add all the purchasing, sales that he has done, and I will also add the insurance that he has bought. So both of them I will add. I will do the aggregation for that particular month, and then I will send it to my OLAP system. Okay. So that what is done in between is nothing but the ELT process. Extract. So it extracts, it loads, and then it transforms. It transforms the data and then it loads to OLAP. Okay. So why do we need to transform? What is the need? Why can't we just push all of it here and then file queries on it? Okay. So let me tell you about that. So suppose we don't do the transformation. So let's try to understand why we need transformation only, and why, and what if we don't do it? Then only we will able to understand, okay, why do we need transformation? Suppose I simply keep on, putting all this data into my data warehouse or OLAP system. And once it is here, once it is into my OLAP system, and then each time, so obviously this particular insight or this particular data will be required by my end users, who will be my analytics team, who will do the business insights, right? So they will be the BI users, they could be the some reporting tools who are using it, or they could be data scientists who are using it. So once my data is here, every time these folks will have to keep on doing the aggregation. And as the data keeps growing, because obviously transactions will keep coming in, and this data is bound to grow. So one more major difference between OLTP and OLAP is this will keep continuing to have historical data and it will keep growing. This will be, volume wise, this will be much more, OLAP will be much more than OLTP. So each time I need to keep doing the aggregations. But while loading only, if I keep the transformation part ready and I do the aggregation, my analytics end users have to simply query that data. That's it. Okay, so and that is because of the huge amount of data. I don't want to keep recalculating. Already the complex queries will be being fired on this OLAP system, and on top of that, if I keep on repeating those aggregations or calculations, it will keep on becoming very compute intensive and compute heavy. So that is why an ELT system in between is required. So these OLTP are basically your Oracle, MySQL, those kind of traditional databases, right? And then ELT happens. You can do it through Python also. You can do through Java also. But if you want to make it more easier, I mean, without any coding, then you can use the tools as well. There's Informatica, there's Talent, then there's Matillion, Fivetran, and so many, right? So many in the market. And these OLAP systems are basically the ones that have huge scalability and huge, storage like Teradata, Hexa, and all that stuff. So now, if you talk about cloud, so these data warehouses are basically what for Amazon it is Redshift, and there's Azure Synapse, and then there is Snowflake. So this is your Snowflake, which is here. It is the cloud data warehouse, and you can have the on-premise Teradata and Hexabase and all as well. So this is where we are interested. So these data warehouses themselves are also capable of doing the ELT. Okay, you can have extract data from here, load into the system here, and do transformations there also. But then you will have to do it through the programmatically. You will have to do all that, right? But if you want to have an ease of no coding, then you can use in between ELT tools. Or actually, this should have been ETL, or this can also be ETL also. It's actually, yeah. So your Informatica and all those are ETL, and then your cloud tools, they are mostly ELT. They will extract, load, and then they will transform here itself. But during the Traditional tools, they first extract, they then transform, and then load it. That's what it happens. Okay, so you understood why transformation is required. That is one aspect. Now let's look. Now that we know that what a data warehouse means, let's look at a typical definition.
I have one doubt actually, Abdul.
Yeah, yeah. Who's this? Venkat.
This Venkat, Abdul.
Yeah.
Okay, okay. You told that OLAP, right, for analytic and processing, we are doing that due to the data size. Yeah, I can understand. But for example, I have insights. For example, Venkatraman is doing the much transaction in the weekdays or weekends. If you start keep grouping, no, end user has this kind of scenario, then how will you do this kind of insights? Whether he is doing no weekends high purchase or weekdays high purchase.
Yes, yes. So see, when your end user or whoever is reporting based on, say, suppose you have a reporting tool called Tableau. There's so many reporting tools, right? Power BI, Tableau, all those stuff. So that will depend on the kind of use case you have. So for example, in your business, I want to know that this particular customer, maybe Venkat, or say in this case maybe Kaushik or Imran, I want to see whether this person is doing how much shopping on weekend and how much shopping on weekdays. That's what you want to know, right?
Yes.
So obviously you will, I mean, this is just a sample, Venkat. So you can have so many columns here also. There will obviously be a transaction date also here, right? So if you have such use cases that you want to see the flow of shopping on weekends as well as weekdays, so your aggregation logic will have to be designed that way. So based on the date, you will group based on weekends also and based on weekdays also. So it depends the kind of insights that you want to derive, and that's where your aggregation logic will have all those processes in place. Understood?
Okay, okay, okay.
Okay, so this is just a sample. You are free to keep increasing the columns as per your needs. Okay, guys. Okay.
Yes,
So
yes.
one
Yeah,
more thing.
one.
Yeah,
Yeah, hi Abdul.
yeah, yeah.
I have one doubt. Does OLTP and OLAP system can reside on the same flavor of the database? For example,
Yes.
uh, MongoDB. Let's take MongoDB. Uh, can OLTP and OLAP reside on same MongoDB?
Okay. So as I said, so I don't have much experience on the NoSQL databases, but let me answer your
Okay.
question. Uh, so this online transaction processing databases kind of stuff. So as I said, this is not very heavy data, which is storing, right? But although it is mission critical, so traditional databases like Oracle, MySQL can serve the purpose here, but they fail when it comes to OLAP. So Hexa database, then your Teradata, and Oracle Hexabase, they come into picture here. Okay, so that is why if you see these are kind of silos, separate. This is separate. This is separate. I need to have different databases with better storage capacities, better scalabilities. Correct. So, but
Yes.
when it comes to your cloud data warehouse, that's where the beauty lies. You can have it, in the single place. That you will get to know once you know the architecture of Snowflake. To answer your question, that is possible now because of cloud.
Okay, then, sorry, one more extended question out here. Since we have both the OLTP and OLAP on the same cloud database, then the transformation, right, the ETL or ELT part, will it be like the batch part, or it will be in real time? Because
Right.
nowadays every client is looking at, I'm just talking about from my side.
Mhm.
If I'm getting too complex, you can stop me there. In
No,
my
no, it's okay.
area, like in my scheme of things, people more rely on the real time. So I work on retail as well, so as you have given example, so they want actually, for a customer that we are building a POC, they want a real time replication to know about the insights of customer buying pattern, or what is the current inventory that is being there. So in the same system, if we have OLTP as well as OLAP, is it added advantage that we will be able to do real-time ETL? Means the real-time in sense
Absolutely.
it is not exactly real-time, sub-seconds actually.
Absolutely. Very good question. That is the very advantage of having it together. Okay. Because, okay, so for the others, for the benefit of others, let me explain them. So what Vinod is saying that suppose a transaction happens, say Kaushik does a transaction of some, some products. So what happens in this system, the one I have shown you here, what will happen is these transactions will keep getting recorded. Then there'll be files generated. These files will land here in some server in between here. Okay. Just let me suppose this is some server here, which is sending some files here of my daily transactions. And say at the end of the day, I want to process all this and put into my OLAP with all those aggregations, ELT stuff. Maybe at the end of the day. So tomorrow, when whole processing of this data happens, then day after my processing team will derive insights on it. So that is what a batch is called. There's a delay. There's a delay in processing your data and moving into your OLAP system. And obviously, if there's a delay, there'll be delay in generating insights. So what Vinod is saying, can it not happen that as soon as Kaushik or some customer does a transaction here, and it directly goes to my OLAP system with all those ELT processes, ETL processes happening in between, and then my analytics can be generated. Vinod, I'm right? You asking this, right?
Yeah, correct.
Yes. So in this case, why it's not possible is because obviously these two sources are different. My OLTP is somewhere, my OLAP is somewhere. So there'll be obviously I cannot have a direct linkage. And because there are so many various sources, even here, for example, for UK, let's talk about data coming to OLTP first. Say for example, UK have hundreds of stores. So I get that data from the hundreds of stores here, and those stores might also be not using the same databases. Some might be storing using SQL, some SQL Server, some might use Postgres, some might use Mongo, some might use Oracle. So I get those files here, then they will have those mismatches in their, maybe data types, or maybe the sequence they generate, all that kind of stuff. Then from India it will come. So there'll be differences. Maybe somebody is using Oracle. So here itself I have to do so much of processing. Then here I have to convert the currencies also. So I have this store is having so much of buying. So there could be in dollars, pounds, rupees, yen, whatever it is. I need to convert it to some common, maybe say dollars, so that I can give it to my OLAP system. So this will take a lot of time because these are not at one place, right? Imagine like this is a shop and this is my warehouse. I need to get my products from here and back here, right? So there I have to travel in between. But with a cloud data warehouse, which has immense capacity of storage, virtually infinite, you can scale up to. Okay, I can keep all this stuff at one place. I can have a one database for online transaction processing. I can have the same data warehouse transaction in the cloud only, somewhere near, and I can have a direct interactivity. So to answer your question, Vinod, there is something called a Snowpipe in Snowflake, which does the real-time processing. As soon as your files reach a particular path, it will quickly, within seconds, sense that and load it into its database. So that utility is called a Snowpipe. So that is quite possible. So I will not go
Yeah.
into detail of Snowpipe right now, okay, because
Yes.
it's quite far in the syllabus. But to answer your question, that is possible.
Yeah. Thanks, Abdullah. Yeah.
Okay. So, okay, thank you for that question. It was a good question. I hope people also got to learn from that. So coming back to data warehouse, guys, let's read out the definition, a typical definition. A data warehouse is a process for collecting and managing data from varied sources to provide meaningful business insights. That's what we learned, right? So these are your various sources: customer management, relation management, billing. There could be enterprise relation system. It could come in files. Then you do an ETL and it goes to your data warehouse, right? So a data warehouse is typically used to connect and analyze business data from heterogeneous sources. As I said, these sources can be heterogeneous. Hetero means different. Homogeneous means same, right? Hetero means different. So this could be from UK. They could be using SQL Server. Some store might be using Postgres, and so on. The data warehouse is the core of the BI system, which is built for data analysis and reporting. So this is your end users here who are into reporting, analytics, data mining, data science. So this forms the core for them for generating insights through this. So this is what our data warehouse means. This does not facilitate business process. This facilitates to do your business analysis. Okay, so that's why it's also called as OLAP, online analytical processing. Let's read the definition of OLTP as well. So OLTP system captures and maintains transaction data in a database, and see, it's called as database always. Okay, and each transaction involves individual database records built of multiple columns. We just saw this this sample kind of data. Okay, we'll do some more insights on this. Examples include banking and credit card activity or retail checkout scanning. Okay, so the one we saw was retail checkout, and also ATMs, when you go to ATMs and when you go to physically go to the bank and do withdrawals. So those are all your online transactions. And see, online transaction, the emphasis is on fast processing. Okay, so if your customer comes to ATM, he wants to say check the balance. The ATM machine cannot flash a message. Just hold on for say 15 minutes. We are doing some analysis on the insights, and it's right now the resources are occupied. Just wait for 15 minutes. We can't say that, right? So it has to be real time. You just click on a click of button. So the emphasis is on fast processing because OLTP databases are read, written, and updated frequently. Okay, if a transaction fails, built-in system logic ensures data integrity. So the data integrity has to be in place here. Okay, so that is what OLTP has to ensure. What is OLAP? We already saw the explanation. Now let's see the proper definition. So OLAP applies complex queries to large amounts of historical data aggregated from OLTP databases, right? And these, it's not necessary that the source for OLAP will be OLTP only. There could be other sources also as well, and there could be some flat files also, or maybe some CRM systems also. So there could be many, and they can go again go through an ETL process. Sorry. So don't think that only this is the source. There could be various flat files, some billing software, some CRMs. Right? So yeah, aggregated from OLTP databases and other sources for data mining, analytics, and business intelligence products. So that is the end user that we saw. In OLAP, the emphasis is on the response time to these complex queries. Each query involves one or more columns of data aggregated for many rows. Okay. Example, year-over-year financial performance or marketing lead generation trends. OLAP databases and data warehouse gives analysts and decision makers the ability to use custom reporting tools to turn data into information. Query failure in OLAP does not interrupt or delay transaction processing for customers, but it can delay or impact the accuracy of business intelligence insights. Right? So obviously, if there is any hardware failure or some issue here, it will not going to impact your day-to-day business. So it will only impact the business decision that you want to make. Obviously that is also important, but at least this actual business process, which you call as BAU also, right? Business as usual, that does not get hampered. So here that might get hampered, but it is tolerable. Okay, let's move forward. So I want to show you one example here. So say consider what typically happens, in your OLTP, you will have customer IDs here. Okay, so there'll be some customer IDs here. Maybe say, 1, 2, 3, 4, 2, 3, 4. Okay. So this, consider that this is not there currently in your OLTP. So you will have customer IDs, and you will have a separate customer table or a customer entity where you will hold all those IDs and the names of the customers. That is what typically happens. Okay, consider that this is not there right now. Okay, so if I say, okay, can you, okay, obviously when I do a business insight, I won't say, tell me the purchase history of customer ID 4. I won't say that. Okay, I would say, tell me the purchasing history of Virat or Imran. Or even for that matter, here there will be product IDs, right? Product IDs. So I will say, okay, I want, so whatever the numbers, let's say that, some product unique IDs are assigned to each product here. I will not write it here. So they will not say, okay, give me the purchase history or sales of product ID 1. They will say, okay, give me the history of iPhone 13, iPhone 11, like that, right? So what I will have to do is, okay, so how will I do that? Okay, I need to find out customer Kaushik. Okay, so let me go back to my entities of customer. Okay, what is Kaushik? Kaushik is, okay, number 1. Okay, he is number 1, customer ID number 1. Okay, let me come here and add a query, filter it out with customer IDs who are number 1 here. Okay, so this is what a typical online transaction database design looks like. Now tell me, I want to ask, uh, is this easy? Or if I have Kaushik here itself, and I say, okay, give me the sales of Kaushik. And if I have Kaushik here itself, is that easy? Which will give me the faster result?
Can't get. Can you repeat again, Abdul?
Yeah, so what I'm saying is, here, if I have, say, customer IDs, right? I don't have the customer names. Okay, so if my customers, if I want to know, okay, what is the purchase history of Kaushik? So I need to go back to my customer table here. I want to see, okay, Kaushik customer ID is 1. Okay, so I will go and fire my query here. Okay, give me the customer ID 1 results. I will filter here with my customer ID 1, right? Give me customer ID 1, and I will do all the analysis. That is one scenario. And if there is another scenario that I have my Kaushik name, the customer name recorded here only. So which is faster for me to get the insights for purchase history of Kaushik? Having Kaushik name here or having customer ID here?
Okay, normally in the detail table, we'll not maintain the names actually. So we'll have the master table where we have the IDs and the name. So whenever we retrieve the information, we'll patch the IDs and take the names because the duplication is avoided. So Kaushik could not be again and again repeated actually. The
Yeah,
extra
that is
column will
fine.
be
That
over
is
there.
fine. That is not the question. The question is simple. Which will be faster?
Maybe without IDs it will be the first without using the names.
Okay, why? Because obviously you can simply do a filter here with Kaushik, right?
Yes,
That's fine.
maybe
Okay.
Kaushik. There may be a lot of Kaushik also. It may take time also. Maybe if you have the IDs, it will be easily finding out and retrieving the information also.
Agree. That's fine. So why I told you is that when you have this kind of a design, when you have customer IDs here, and then you have a master table, which holds your customer IDs and names, this is kind of normalized database. Okay, so you have properly designed, okay, my masters tables will be here, my transactions will be here. So now if you want to know some insight, you will have to go and join with my master table. and then you will get proper data. So this is called as normalized form. And a typical online transaction processing is in normalized state. Okay, but in your data warehousing, it is highly denormalized. Why? Because the emphasis is on the response time for these complex queries. Okay, so you need a good, faster response. So you will store a customer ID also. It's not that you will not store that, but along with that, normally the search patterns, say from customer name, I'm trying to search, from customer mobile, I'm trying to search. So those searchable patterns will also be stored along with that in this transaction history in your OLAP, so that I don't have to go back to my customer IDs. Okay, so normally so I wanted to highlight one difference. Basically, my OLTP systems are normalized forms and my OLAP systems are highly denormalized. That's what I was trying to highlight. But yes, this will lead to data redundancies. But we already said that this particular data warehouse will always be heavy storage data warehouse. This will store a lot of data. We already said that. So we had to take those considerations. Okay, so if you have a properly normalized data design for your data warehouse, it will be a problem as far as query performance is concerned. Okay, so you have to take care of that while designing, that it should be in a denormalized form. Okay, you store the IDs also. I'm not saying don't store, because as Venkat rightly pointed out, there could be multiple Kaushiks. He rightly pointed out, and there could be a problem to understand which Kaushik is which one. So that will only be identified by unique ID which you associated with that particular customer. But if you want to also search a lot of patterns, say customer name, what is his address, and what is his mobile number and all that. So that also you can store along here during your ELT process. So when you are doing your ELT here, right, when you're taking data from OLTP to your OLAP, that time you can store those other fields as well, just not the customer ID, other fields also. So this is a denormalized database always. That is why I wanted to tell you that. Okay, cool. Now so this particular example here, what it says is, my online retailer, I have 3 entities. There could be many. For this particular example, I'm taking 3. There is a customer entity, there's a products entity, and this is a courier service. Okay, so I am selling my products. I have a big customer database, people who keep buying from my store. I will record their details. So whenever you go, if you go to a Domino's, they will ask for your mobile number first, right? If they have it in their database, they know everything about you. Okay, this is your name, this is your address, this, that. Okay, sir, will deliver it to you. But if you are a first time purchaser and they will ask for your details. They'll search by your phone number and say, okay, you are not in our database, let me record your details. And they will add your details here. That is the first thing they do, right? Before delivering the pizza to you. So that is how my customer database gets inserted every time a new customer comes. If it's an old, it will take it from here only, the data for that customer. So this is my products details. What products do I have available? And these are my courier services. If I'm an online retailer, I will assign my courier services to each transaction. Then, okay, this transaction has been done. Go ahead and deliver this product to so and so customer. So if you see from this transaction history here, you always, whenever you're recording a particular event of sale, this is called as event of sale, this particular transaction. Okay, so always you will record the customer, you will record the product he bought, and you will assign a particular courier for that particular customer. Okay, and then there'll be some other factors. So this will give you a textual description from this record, from this event. What it will say: who is the customer, what did he buy, and who is delivering it. So who, what, how, that are the questions that you can answer through these fields. Isn't it? And then there'll be other fields like how many, what was the quantity of purchase, number of items they bought. I mean, so he bought one item. What was the price? What was the status of returning? Did he return back the product? If there's no reason, not applicable. If there is some today's date or whatever date he bought that particular product, you can record it here. So if I have these, and I will assign a particular courier to him. So always, when you can describe that event through the help of some fields, like who bought it, what he bought it, and how he bought it through delivery or whatever, that is called as a dimension columns in the terminology of data warehouses. So you must have heard a lot about dimensions, facts. If the ETL guys are here, they will have heard about it. So they are nothing but your dimension tables. When they describe who, what, when, why, okay? So those are your dimensions. So here, my dimensions is what? Customer, product, my courier. So, and these are also, created as your master tables. So I will have a separate customer dimension. This is my customer dimension. And I will store what? I will store the customer. I will store the customer ID. I'll customer name, address, day of birth and all that, gender, income, all that stuff. So this is also called as my dimension table. And this is also, some people like just Venkat was saying, I will have master detail relationship. So this is my master table also. Some people call it a master table, but data warehouse terminology, technically speaking, you have to call it as a dimension table. Okay. So what it does, it describes, I'm not reading the first one. Don't worry, I will read out that later. So it describes who, what, when, how associated with the event. So who was associated with this sales event? My customer, what did he buy product, when, what was the date of buying that, and how did he buy? Did he, like, it was cash or Google Pay, Paytm, whatever. It has fewer rows, okay, but can be wide with many text columns. So this will obviously will be very fewer rows, right? Okay, it will just record one customer detail. So if you have say 10,000 of customers, so for each customer you will have just one row most of the time. Okay, so there is something called as SCD also. We'll not talk about it right now. We'll talk about it in the middle of the course. I don't want to complicate it right now, but consider for each customer you will have one row each. And you will have a lot of information against him, what he likes, what is his hobby, this, that, so obviously the purpose is to understand the psyche and take out the business insight out of it. So these are your dimensions. Similarly is for the product. If you have tens of thousands of product, against each there will be one row, and you will have various. So if you create as a table in the data warehouse, you will have an ID, you will have prod name, you will have prod description, and you will have the stock, what is the stock, and all that stuff. Okay. Similarly for courier services, you will have the ID, you will have the courier company name. Okay, you will have a courier code or whatever extra fields you require. So those are your dimension. Okay, and always there will be some primary key associated to your dimensions, right? So your ID will be unique. For example, as we know, Venkat said that Kaushik, there can be 2-3 Kaushiks, right? So how do we identify? So we'll be assigning IDs to them, unique IDs. So Kaushik can be 1, the other Kaushik can be 2, and so on. So this will be your primary key. Primary key is always unique, okay, and it cannot be null. That is the property of primary key, right? This will be your PK. So that is your dimensions, guys. And you must have heard what? That along with dimensions, you have something called as fact also. So what it does, It stores the performance measurements resulting from an organization's business process event. It's saying it stores performing measurable factors or say attributes from a business event. What is the business event, guys? It's the sale that happened, right? And how do you measure the performance? Through the number of sales and the price, the sale you got. So basically, these are your measurable items. And these measurable items, which is your price, quantity, these are always stored in a fact table. Okay, these are never stored here in dimensions. These are always stored in your fact tables here. And during each business sale event, here there is no event. This is just a simple master data you are collecting for each customer, for each product, and for each, for example, tomorrow there's a new product, you will add it into this particular table, dimension table. Okay, so to have a customer recorded in this particular transaction or a product or a courier, they should be existing in these tables first. Okay, so tomorrow say I have a new transaction here. Okay, and say this is my, I say I don't have the customer ID and this is Venkat. I will not be able to record this transaction because this first has to be present in my dimensions. So this is called as a foreign key relation, guys. This is my fact table. I have created my fact table. So these will be the columns in my fact table. And how do we identify it? Through the measurable attributes. And what are the measurable attributes? They are basically anything which are numbers through on which you do the aggregations. So my quantity, my price, these are my measurable fields, and they are also always recorded in the fact table. So I was talking about coming back to the customer dimension column here. So this dimension column, which is recorded in the fact table, it has to come from my dimension table. It has to be within these values only. Okay, so which is why this particular column becomes my foreign key. It is called as foreign key. What is my foreign key? It is my foreign key to the customer table primary key. Okay, it is called as a referential integrity also, which means my customer ID, it has to be existing here, somewhere here in this table. If it is not there, I will not record the transaction. So this is my primary key and this is my foreign key, my customer ID. Okay, so and foreign key is always related to a primary key of some other table. It cannot be, okay, it cannot be my foreign key to name. It cannot be that. It has to, the rule is my foreign key on my table, on my fact table or whatever table it is. Suppose this is my fact table and I am saying my customer ID will be my foreign key. So it can be my foreign key only to a primary key of some table. So my customer ID, so I am saying my foreign key will point to my customer table. So I will say, okay, which is the primary key in this table? It is the ID. So, okay, so whatever my values will be stored in this fact table under the column table, under the column customer ID, that can have only values here, whatever is here, 1, 2, 3, 4, 5 against each customer. That is what it means. Any question on this foreign key, primary key stuff? It's quite basic. I mean, you guys are all SQL experts, so I'm sure you will know that.
Abdul, one thing, Abdul, Armum here.
Yes.
See, in our project, there are chance where we'll get a transaction before we are getting that customer in the dimension table. So what we would do is, if we don't find an entry in the dimension table, we'll discard that record and load it into a flat file. So tomorrow, when the entry comes to the transaction dimension file, and then we reprocess that in the fact table. So it doesn't mean that always we'll get a dimension first and then other fact. In our project, it happens. So we get a transaction first. So we handle in such a way. So I just want to highlight this.
Awesome. Because I was going to come next to that point only. Good, good you highlighted it. So
Okay.
yeah, so I was going to give one example here. Okay, so firstly, I believe foreign key, primary key, there is no issue. Okay, if any issue, please feel free to stop me and ask me. Okay, so let's talk about a condition or a situation. Say Venkat, he buys a product, say one, he buys iPhone, okay, and he buys one and say for 50 or 60K. Okay, so I put all this information. He's doing an online processing and I am recording this. Okay, now right now I don't know. So as per the address that has come up for Venkat, so here I'm assuming that Venkat is there in my database. Let me add his name. Okay, guys. So his address has come up and everything is come up. But I see that in that address, I am not able to decide which particular courier service I can allocate to him. Right? As per this table, I should be allocating some courier ID here, right? Okay, that okay. To this particular address, my say my deluxe can go or speed fast can go. I'm not able to do it because right now I'm not able to make out looking at the address where Venkat lives. So my question is to Chidambaram, should I record this transaction or and say, okay, once we are able to decide what what the courier we will be assigning to you, once we are able to decide, we will record this transaction. Till that, please wait. Can I do that? My question is to Chidambaram.
Yeah, we can make an entry based on like the record we got into the dimension table.
No, I don't know. So I have these entries in dimension tables. Okay. Currently, what my question is, I don't know which one to assign here. This courier. It could be a new, altogether new courier service, which I will be, doing my contract with and saying, okay, these areas, whatever these areas are there, you will be responsible for delivering my products. It could be either a new contract, which I don't know currently at this particular business event, I don't know, or it could be some other from the existing also, okay, from the existing also, but I am not able to decide it right away of this particular moment. So can I record this transaction? Because see, if whatever courier ID I have to give here, that has to be in dimensions, right? This is my foreign key. This courier ID is my foreign key to my dimension courier here, to this ID. So right now I don't know what ID to assign to this transaction. So will I so what should I do as a business? Suppose you're a business person. Will you go and record this transaction without the courier ID, or will you say, Venkat, please wait for 2 days, come back, log in, and till then, hopefully, we'll be able to assign some courier to you. Then you can do your purchase. For what will you do as a business person?
So I will get the courier details or
You will do what? Sorry. Okay, no problem. Chidambaram, just think over it. Think over it for some time. Let me go to Arumugam. Arumugam, what will you do? The Arumugam Punni Viyanam. Sorry guys if I'm not able to pronounce names correctly. Extremely sorry on that. Yeah.
Yes, Abdullah. See, I cannot load this transaction because the key column cannot be null, and also I cannot ask the customers to wait until I find a courier. So I will not take this transaction at all.
So you're going to say, okay, come back after 2 days or 3 days, once I'm ready to assign some courier to your address, correct?
No, either way, I can take this transaction because anyways, I'm maintaining a historical records in the data warehouse. So I can load this transaction. So whenever I find a courier, I can update this transaction, just maintaining the history, or I can discard this transaction and I can reprocess the transaction when I see a courier agent. So,
So
either
what,
way, I cannot.
so what will you put here in courier ID?
-1. Whenever I find a null for this transaction, I'll be defaulting that to a -1.
So you are going to put -1 here.
Yes.
But will it allow you? Because it's a foreign key, it has to take values within this database only.
Yeah, in my ETL, I'll be have a logic whenever I don't find ID, looking up the dimension. If I don't find an ID, I'll be defaulting that to a -1. Or I can create a default option of the database for this column as a -1. Either way, I can handle this.
Okay, so you can say default courier here,
Yes.
and this will be your -1. So if you don't,
Yes.
if you don't find anything, you will say, okay, right now let's keep it to default,
Yes.
and whatever, we will process the transaction.
Yeah,
Okay.
I'll process once I find a right courier for this person. I'll update this transaction to the right person.
Right. So basically, you will not stop your business. You will take the money from Venkat. You will say, okay, this is my 50K, 60K. It should not go somewhere. I will take this 60K, and later on, obviously, as a responsible business person, you will update it quickly only. You will find the proper courier maybe by tomorrow. But you will do that. But as of now, you will not stop the transaction, and you will not let this money coming into your system, right?
That's right.
Right. Okay. So then, okay, fine. That is one way possible. You will have this -1. You can have it. You can have a default entry here and -1. That is fine. Okay. Suppose. So guys, there are no correct and wrong answers here. We are just trying to think what can we do. See, we cannot let business go, right? Any person, as a business person, if you think, you will not be interested to let your business go, right? So what Arumagam did, he created a default entry already in dimension table and assigned it to it, but you will do an update later. Okay, fair enough. Suppose now, okay, Aru, not now. My question to another Arumagam, the one who did not speak right now. So can you tell me, Arumagam, if I don't have, I did not foresee this, whatever. I did not foresee this situation. I did not have this. Okay. And I'm not able to add right now this -1. So what should I do? Should I let it go, or what should I do? Hey guys, am I audible?
Yes, Abdullah, you're audible.
Okay. So Arumugam, can you please answer this? What can else can I do here? Okay, no worries. Arumugam, you can think over it. If you have some answer, do come back. Not a problem. Venkat, what will you do?
Maybe I'm not sure about data, but no, this data will I use for the assign to the new providers. So I need as an insights, which are the areas I don't have the courier or delivery agent. That data I need for my business to improve. So maybe I will insert this data. I'm not sure what the, like Armugam said, null value or some value will be defaulted. Thus data I'll pick out and use for my business purpose to quickly to resolve. If within 1 or 2 days I could not able to resolve, I may return the what are the goods they purchase also.
I think that's a very good answer. You have, I mean, of course, you have not answered what I have asked, but you have created an insight out of it, which is very good. That okay, which are the areas I'm not being able to cover? That is also one insight for business, right? I need to have those areas where I cannot currently I'm not able to reach. So it's a very good insight you have taken out. Very nice. But to answer my question, say you are going to record this transaction. So what will you put here in the courier ID? Because this is a foreign key. Okay, I told you this is a foreign key, and it should have values to the primary key of the table it is associated to. It is associated to courier table, and all those values should be within ID only. But I don't know which one to assign right now. So But I had to record this transaction also because I cannot let my business go right away. You're right. If I'm not able to assign any courier, I will, after 2 days, I will say, okay, I will return back your money. Sorry for the inconvenience. But I cannot say that upfront. Otherwise, I lose. I will try, right? I will try for 2 days at least. Okay, let me, get the money and let me try my best for delivering the courier service. So my question is, when you are, from a technical perspective, when you are recording this transaction in your fact table, what will you load here? I mean, you don't know what to load here.
I'm not sure of the.
Okay, no
Maybe
worries.
what Armuga said. Maybe I think the default values
Yes,
only. I think.
yes. That is also a good way of doing it. So let me tell you the property of foreign key. Okay. So this is my fact table, guys. These columns will be there in my table, right? This will be created as a attributes for that particular fact table. And I will be saying customer ID, product ID, courier ID. These are my foreign keys. My customer ID is my foreign key to who? ID of customer table. My product ID is foreign key to who? Product ID of my product table. My courier ID is foreign key to who? Primary key of my courier service table, right? And these are all my dimensions. So the property of foreign key is it has to be from the values within the range or within the domain of this particular primary key that you are referencing to, or it can be null. This is the property of foreign key. Okay, guys. So you can very well go ahead and log or launch this transaction in your data warehouse, keeping this as null, and come back later and update it. So you can very well do that. So that is because the foreign key property is such. You can always keep a null here. Okay, guys. So that is what I wanted to explain to you. Now, sorry, is anybody waiting you?
Yes, Abdul.
Yeah. Now, somebody told that, in cases where, we don't have the dimension values, they still go and launch the fact, right? So what people do is in say real time, what they will do is, let me just quickly say from this example only. So what they do is in this case, we don't know the courier ID, right? We don't know the courier ID. What they will do is either they will keep it null and update it later, or what they will do is they will put this in some other table. They will say, okay, I am putting some records in one table where I'm not getting the full information. I'm maintaining that other table. So by say tomorrow, I'm able to full the dimension records. Okay, some new courier ID has come, or maybe I know which courier ID I need to assign to it. So I will go and check all those records in that particular table for reprocessing. So that is called as a reprocessing table. There I will assign the dimensions to them, the keys that were not present a day before, and I will put it back to my main fact table. So that is some real life scenarios that happen. So Arumugam, I think you, or Venkat, I think you highlighted this, right?
Yeah, either way, either I can load that as null and then I can update, or I can load that to a separated table, what you told, like a reprocessing one, the two way you can do it.
Exactly. Yeah. So guys, this is all about your data warehousing. And I told you what facts means, what the dimensions means. Quickly, let's read the definition of facts. So fact stores the performance measurements resulting from an organization's business process event. And fact represents a business measure. Each row in the fact corresponds to a measurement event. So it's all about measurements, which is basically your money, your number of items and all that. Then grain. What is a grain? The data on each row is at a specified level of detail, which is your one row per product sold on sales transaction. So basically, when you want to have the minutest detail of a particular row, so what is the detail here? Product iPhone was sold to Kaushik. That is by grain, basically. So that is the one row per product. So these are my products, right? So per product, this is my one row. So this is my grain, my customer and product. So that is how you call it a grain. You specify the minutest level of detail for that particular row. Then facts are continuous values. Okay. So two or more foreign keys that connect to the dimension table's primary keys. That's what we just discussed, isn't it? So these are, so facts have a lot of dimensions. Customer is a dimension, product is a dimension, courier is a dimension, right? And these will be foreign keys. Product ID, customer ID to my dimension primary keys. These are my dimensions, customer, products, courier, and their primary keys, I will be pointing to them as my fact foreign keys. It can have its own primary key also. So facts can have their own primary key. We normally call it as a surrogate key also. This is, you can, which basically identifies each transaction uniquely. It will have its own primary key. So you can say the serial number here is a primary key. You can call it as a transaction ID also. Okay, up to you. And this is also called as a surrogate key. It's kind of just a sequence that you are giving it to. One transaction. And it can have many to many relationships. That is what we saw, right? So it can have relationship with product table, with customer table, with your courier table. So if you look at the design, it looks like something called as a star schema design. So you have this fact table in between, which is recording your transactions, guys. And it is associated with the primary keys of each dimensions, right? Your dimension, customer, product, courier service, and so on. So this is how when you create your tables, this is how it looks. When you generate a ER diagram out of it, this is an entity relationship diagram. We call it as ER diagram. And this design, it's called as a star schema. So it gives a feel of star, right? Looks like a star. So that's why it's called as a star schema. So enough of data warehouse, the basics that we need for learning Snowflake, that much we have covered. Okay, so this was important to cover because Snowflake, as I said in the beginning, this will be your data warehouse only, but it's in the cloud. We will see more detail on that. So we needed to know all this stuff for that, which is why we spent some good amount of time learning this. Any questions still here, guys? Okay, so next we are going to look at cloud. Can we have a break of 10 minutes and then come back? Is that okay?
Yes, Abdul.
Yes, Abdul. Okay, Abdul.
Okay, guys, let's regather back in 10 minutes. I'll be back. Okay, and then we'll start with cloud.
Okay.
Hey, hi everyone. Is everybody back from the break?
Yes, Abdul.
Yes.
Okay, great. Let's wait for Venkat and Vinod. So we have two Arumugams here. Okay, sorry. Okay, I have logged in as Arumugam. Hey, hi Vinod, you're back. Okay.
Yeah.
Venkat, you're also back. Okay,
Yes, 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 Abdul.
great, guys. So let's look at some stuff now. Okay. So guys, see, I want you guys to participate. Okay. So my style is that I just, whoever is learning, I just pick random person and I ask questions to them. Okay. So please, interact and try to, if you don't understand, definitely, please feel free to ask. There's no issues. Okay. Ask me any number of times you want. So I'm going to ask Vinod. Okay, Vinod. So you are supposed to organize a marriage, okay, maybe of your son or yourself. Okay, you, as per you, I leave that to you. You are the organizer. You are going to do all the stuff, whatever is required for a successful marriage. Start telling me what all areas, departments you'll be starting to look into.
So if I'm looking for my son's marriage, first I look for a bride, basically.
Awesome.
Then
Awesome.
some auspicious date, then marriage hall, caterers, and decorations and transport,
Transport of
and
guests.
transport of guests, guest rooms, basically some kind of a resort
Accommodation.
or some accommodation. Yeah,
Okay.
and finally, if I'm going to fund for my son's honeymoon, then honeymoon travels, all those things.
So let's talk about the day of the marriage. Okay.
Okay, these are the things.
Okay, cool. So, guys, even you guys are invited to his son's marriage. Okay, so would you like to add anything? Arumugam,
Yes.
Chidambaram, Vinod.
Invitations.
Mm.
Awesome.
Dresses.
Invitations, dresses. Okay.
Written
Okay.
gifts.
Maybe written gifts.
Okay.
Jewels.
Music, maybe DJ music, maybe. Maybe parking area for people coming in. Okay, maybe some. Okay, so caterers will take care of all the snacks and all that stuff. Okay, fine. So I think this is good enough on a high level. Okay, so let's not take the bride here. I mean, obviously, bride is required. So we're talking about the infrastructure, stuff basically, and obviously there has to be some date. Okay, cool. So, Vinod, all this stuff, right? This hall, this transportation, this decorations, or maybe say this invitations. Will you be purchasing all this? Maybe will you be purchasing the hall? Will you be, purchasing
No,
some
by invitation.
shares? So
No,
all
I'll
this,
rent the hall, pay for the caterers for 3 course meals,
Mhm.
decorations. I'll just rent whatever it is necessary, and some perishables. If it is a day old, then I will buy it. Or else
Okay,
we will rent basically for parking area. We'll rent for transportation of guests, some vehicles,
correct. For
and
invitations
accommodation also.
also, you will not.
Invitations we buy. Yeah, we'll buy invitations. Dresses we'll buy. Gifts we'll buy.
Yeah, what I mean is for invitations, you will obviously outsource it to someone who has a printing press, right?
Correct.
Who has printing
Yes,
facilities.
yes,
You will not go and
yes.
okay say okay, let's wait for till I construct a printing press for myself, and then
No, no,
maybe after 2 years we'll get back. You won't do that,
no,
right?
no, no,
Cool.
no.
So why will you do all this? I mean, why don't you purchase it yourself?
But see, if, it's going to be a 2-day marriage or a 5-day marriage. So why do we need to buy everything on our own? Since it is available, why don't we leverage it basically?
Okay, cool. Any
And
any
buying everything is a huge cost rather than renting it.
awesome costing? Okay.
And maintaining it, if you are going to buy marriage hall, then you have to do a maintenance, and maintaining it is also going to take a huge cost.
Very good. Yep.
Yeah, those are the
Your
reasons.
time,
Yeah,
time
time.
waste.
Yeah, basically, yeah, timely. We
Correct.
cannot do it in a timely manner. Yeah.
Awesome. So guys, why I gave this example is basically to draw an analogy. Okay. So this is an analogy I want to get into, and we'll see what. So can we not, this is a huge event, right? This marriage, this is a huge event, and so many things are involved. It's like food area, food department, then your guest department, then your, other logistics that are involved for transportations, etc. So if you are having say thousands of guests coming in, you cannot buy Volvo vans and those vans for them and then keep it in your backyard forever. You can't do all that stuff. So this comes with a huge cost, and this is just a 5-day activity, as Vinod rightly mentioned. So let's now talk about this in terms of a business. Okay, so you have created say a manufacturing, or not manufacturing. Let's stick to retail business. Okay, something like Flipkart. So obviously you will need a lot of stuff there, right? So you will need a lot of servers for the computing needs, isn't it? You will need a lot of storage stuff to store the data for you, the incoming transactions, the surveys, the product details of your company, what stocks you have, the inventory management. So many things are there involved, right? So you will require so many servers. You might require say thousands of servers if you're on a large survey. Even this is a less number, but I'm just saying. Storage also you will need in terabytes, petabytes, even going above them. And this is simply increasing. Then you will have a lot of network management also to do, right? If you're on the web, you need to connect to the people. You need to have the network devices, the routers, the modems, and connectivities, and not what not, right? And a lot of other hardware stuff. Okay, even you need to install apps as your softwares. So imagine the cost that comes here, and imagine as a company the management you need to do by hiring people for this, and also imagine the time taken to install the whole infrastructure. Okay, so your time to install infra, your planning, capacity planning. Okay, you cannot say okay, I'm starting my business today, And today I need 100 servers. So as per today, let's install 100 servers and we'll see what happens tomorrow. Because to be a good businessman, you need to have a good business acumen and you need to be a visionary who will see at least 5 to 10 years down the line, right? You need to do business in that way. You have to have a vision. So capacity planning has to be done. So you need to hire technical people, then you technical folks required for that. Then there's management of this. There's capex involved, which is the initial, capital expenditure that you need to do for all this stuff. So is it not a similar analogy for the marriage? Of course, this is an ongoing business, but this is a day-to-day, I mean 5-day activity and all. That way, it's not the correct analogy. But as far as the cost and the installation of the infrastructure, the management, the logistics, it is somewhat similar, if not completely, somewhat similar, right? And I mean, if you are looking into caterers, you cannot go and look into each dish. Okay, this okay. I need to look into biryani also. I look into the raita also. I need to know what raw materials to get for the caterer. You cannot do all that. I mean, otherwise your son's marriage will happen after 10 years. So this is all so much of overheads when you do it all by yourself. Okay. So why not I say, okay, somebody take this headache for me. All this stuff. I don't want to get into this headache. Okay, as a business person. As a business person, I just want to know, I want to just do my insights. This is what I'm interested in. I cannot waste my time doing all this. Okay, I want to know, okay, what kind of incoming transactions are happening. I want to know the stores that are performing, the products that are performing, people who are not performing, the courier services which is not performing well. For example, there is an insight here. If you look at this particular data here, is that, yeah. If you look at this Virat, he is buying some shoes or something, and the courier assigned to him is first flight. And if you see all their records, they are always delayed. They firstly the status is delay, and whatever they deliver is defective, always. So if you see from their courier history, it's always defective. So I know, okay, I need to give warning to this particular courier, or I might need to change it for good. So I am interested in all that. I want to know all that as a business. So why not I ask someone or source it out to someone else and say, okay, you do take care of this, the whole infrastructure stuff. So in the market, there are folks or companies who do this. So do you know who they are? Who do this for you, for the business? They'll say, okay, you don't worry about servers. We are going to install servers. We are going to give you storage. We are going to do the networking. We are going to hardware, everything. So who does that for you?
Cloud providers like AWS, Google, and Azure, Microsoft.
Very good. So these people who provide you all this stuff, this hardware, this infrastructure management, these providers are called as cloud providers. Okay. And there are quite a few in the market. Of course, the famous ones are AWS, Azure, GCP. Now Alibaba has also come, Jack Ma's. Then Oracle also provides its own cloud also. There's so many others, you know. So but the main players are Azure, AWS, and GCP. These are the people who are doing this for you. So let's look at the definition. So see, what is cloud computing? A general term for anything that involves delivering hosted services over the internet. These services are broadly divided into three categories: infrastructure as a service, platform as a service, and software as a service. You must have seen these terms: IaaS, PaaS, SaaS. So it's nothing but, you can always remember IaaS as a service, and the first one will be I would be infrastructure, P would be platform, and S would be software. And the name cloud computing was inspired by the cloud symbol that's often used to describe the internet in flowcharts and diagrams. So we draw algorithms using flowcharts for the flow of logic. So for the if-else condition, we have this diamond shape, right? For diamond shape, then for some statements, we have this rhombus kind of shape. So similarly, there's a cloud shape for internet, which is why they called it as cloud computing. Okay. So what will happen is, so guys, even when you guys log in for your work, all of you, so do you have your softwares installed on your laptop provided by the company? No, right? The place you want to work, which is your work area, is somewhere on the internet, and you connect to that through a VDI, right? Virtual desktop, right? You never have things installed on your laptop, correct? So
Correct. We
say
access through HV.
Yes, yes.
Yeah.
exactly Citrix and all that, right? So uh, this is your say laptop, and you basically connect it to a VDI somewhere, and you are basically accessing it through the internet. So what AWS, Azure, GCP will tell to our business that, okay, this is us, this is our company here. What's the problem? Cloud. This is our, company here. And here we have everything for you. Whether you talk about servers, whether you talk about the network, software, everything. These are our service. And all this will be delivered to you as a service. We will be giving you as a service. For that, internet is required. Otherwise, you will not be able to access our services. So internet is mandatory for cloud access. And if you want only hardware, okay, that is the computing resources, the storage resources, network resources, which is under the category of infrastructure, we will give you that, and that would be called as infrastructure as a service. But if you want us to install particular operating systems, like maybe operating systems like what, Linux, Windows, then we will give you that as a platform as a service. But if you want to also use our softwares, maybe Amazon has some database services also, like Redshift and all that. And so that also will give you as a software as a service. So three things we can give you: infrastructure as a service, platform as a service, software as a service. And you have to pay as long as you are using you're using my compute resource. This is my compute resource, and you're using it for say 5 hours in a day. You have to pay only for those 5 hours. And once you shut this down, you don't have to pay a single penny. So this is also called as pay as you go model, pay as you use model, right? So here, if we buy all this stuff, so here also we are doing what? Till the time we have used your stuff, we'll pay you. Till the time we have used your car, we'll pay you. Till the time of your music time we have taken, we'll pay you. Till the parking area time we have taken, we'll pay you. That's it. Once we are done, we are done. So here also we are doing that. And say in my business is thriving. I immediately need to scale up to a more computing resources. I can do that immediately for you as a cloud provider. Immediately. Okay, say my capacity planning goes wrong here. If I'm installing all this stuff, it can go wrong in two directions. Either I have overestimated, okay, I have bought 5,000 servers and I just needed 500. It's a total waste. What will I do with all that stuff? Okay, and that is what actually happened with Amazon, and which is why they came up with this cloud computing stuff. They had overestimated, and then what to do with this stuff, so they outsourced it, and then they started the cloud stuff. Okay, so they are the pioneer in the cloud computing area. So yeah, so that's the point. That's one point. The other point is, if I have underestimated, and if I'm taking care of all this, how can I get additional servers in a day? I mean, I'll have to install them, I'll have to do patching, and I'll have to connect it to network and so much. At least 1 or 2 weeks will go, right? But I am saying here as a cloud provider, just tell me you need this many servers, this much storage, and it's immediately within seconds or within minutes it's available to you. So it will, that is called a scaling up or scaling down, right? So I can do that for you within minutes. That's what they say. And who are these guys? These guys are your Amazon Web Services, Azure, GCP, and so on. This is what is your cloud. And this is what, when you do it yourself and it is in your company area only, it is called as on-premise. On-premise means, okay, I have installed it in my area. For example, I have installed this software developer, sorry, SQL developer here, which connects to Oracle, and I do my queries. So this is my on-premise client. And my database is also on-premise. This is my local laptop, or my personal laptop. So my database is also installed here only. So this is my on-premise. But this is my cloud. It's somewhere else, like similar to your VDI, your Gmail accounts, right? Similar to this VDI you're accessing. This is somewhere in the cloud. So this is what the cloud providers give to you, the facility. And what are the different services they give you? They can give you storage, okay, mobile computing. They can connect to applications. They can give you database services, computing services. Servers means computing services only. These all services they can give you, and much more to that. And these can be in different kinds. It could be a private cloud, it could be public cloud, it could be a hybrid cloud. So your all the websites that is accessible to you, it's nothing but public cloud. Your private cloud is basically restricted to your business purposes. Okay, so what happens is, if you want a private cloud, we will assign a few resources only for you. Okay, so all these resources are only for you. That's it. We will not be giving it to anybody else. In public cloud, what they do is they don't reserve all this for you. They have a pool of resources. They say they will have a pool of 100 computers, and whatever is available, that they will give you from that particular pool. So that is your public cloud basically. Okay. So, and hybrid will be obviously a mixture of both public and private.
Abdul, one question.
Yeah.
If I go with a public option, is that mean that whatever the data I store in the cloud can be viewed by the other person also?
Yes. So the security is your concern then in that case.
So if that is the case, then most of the company will go only for the private option, right? Then what is the use of public?
No. So see, your Gmail is a public cloud because it is accessible through a website. So I mean, your companies will not want to expose their private data to anyone else, right? Unless, of course, I mean, if it's a retail, you will have the online front end in front of the people. But whatever insights and all that stuff that you're doing behind using that data, that is not exposed to anyone. So that will be, and that requires, for example, financial systems, they require a lot of security, the defense systems, government projects. So all these big players go for your private databases. I mean, sorry, private clouds. But Amazon will have a hybrid one, right? Some part will be private and some part will be public. And guys, to learn Snowflake, you don't have to be very, champion in cloud. I'll tell you why I'm explaining this, because this has got relation with Snowflake. So which is why it's important to understand what cloud is at least, and some services. So which I am explaining you right now. Okay. So this is diagrammatically, this is your on-premise and this is your virtual cloud. So you just need a laptop, and you through internet you are connected to your providers, AWS or whatever. And even hybrid cloud means that you can also have multiple cloud vendors supporting your business. So some services can be on AWS, some services can be on GCP. That is also a part of hybrid cloud, kind of hybrid cloud. So this is your on-premises. So see, even so, in case, so had you not had your VDI and you had to say connect to your company network only and do your stuff, so in COVID also the whole business would have come down, right? You would have had to go to company only because you can connect to their secure network and do your stuff, right? Otherwise, your laptop won't work. Even from home, when you connect to the network, you connect to your company's network and then access the VDI. But had it not been, if it had been on premise, then you would have had to go to the companies. So this is also facilitating. It may ensures that your business doesn't come down. And cloud services, 99.999% they don't come down at all, unless there's a natural calamity, there's an earthquake or something, some landslide. Everything goes down. Then obviously nothing can be accessed. But apart from that, virtually everything is accessible all the time. It doesn't go down. So this is how it looks pictorially, okay, on-premise versus cloud computing. And a good example or analogy is, see the wallet in your, the wallet that carries your money in coins, etc., credit cards, that's your on-premise. And the money that you keep on the bank, that's your cloud. Okay, so this is a kind of analogy that you can draw from the cloud. Okay, guys. So I think for today it's enough. Tomorrow we are going to see one use case also. I wanted to cover this as well, and show you some services. But we'll cover it tomorrow. I mean, from 8 to 10. Is that okay?
Yeah, yeah, Abdullah. If we are actually final stages, I would like to get something clarified. This is not nothing to do about this cloud part, but from whatever I experienced in the previous projects, I was part of it. It is nothing to do with whether we need a cloud or on premise, but some of banking clients, right, to be on the saver side, they still go with the hybrid model actually. Like some of the business critical, they keep it on premise, whereas some of their businesses they still put on cloud. So one thing is like what I heard from the directors or the client partners they are associated with, they are still apprehensive about the data security part. Though you can say like in the cloud you have all those TASF certification, HIPAA certification, and all those things. They are approved federally and all those things. Many of the clients in my knowledge actually, it may not be a generic one, but in my knowledge most of them are still apprehensive on the cloud side. And second thing is when you are going to go for a cloud, right? So when you're going for a on premise, you will be forecasting some kind of return on investment, so that if I invest x amount of dollars or rupees for 5 years, I'm going to get those returns on it. And whereas when we go in for a cloud, the differences altogether, it's like minimal difference that they see. So when you invest so much of dollars on cloud, it is the same that we do on the on-premise. That is what many of them think. But it could be a different scenario for different clients. But many of the financial clients, like banking clients, like Citi or Bank of America kind of thing, they still have this hybrid model. So these two questions, you can give an answer in very short if it is we are
Yeah,
going to
yeah,
the final leg of the training actually. What do you
yeah. No problem, no problem. Yeah, so it's a good question, and so I cannot tell you the client that I am working for. It's a banking client, okay, and they have decided to move their entire stuff to GCP, Google Cloud. Okay. The thing is, the migration to cloud is very nascent, and it is just started from past some years. Okay, and it is not easy to migrate the traditional systems to the cloud data warehouse, whatever you choose, be it Redshift, Google, BigQuery, Snowflake, whatever you choose. It's not so easy because you have so big and complex systems that you might do it in phases. So that will take
Yeah.
time, firstly. The other stuff is what you're talking about, that apprehension in terms of security. Obviously, I mean, there will always be those apprehensions. But as far as security being provided by the cloud as of today is very, very, very powerful. Okay. It does not necessarily mean that if you are on-premise, nobody can hack into your system. That also is not, that is also not 100% proof. The
Yeah.
other
Yeah.
system is
No system is foolproof. Exactly what you're
exactly,
saying.
exactly. And the other stuff is there is no chance you can do your business analysis or data science on the ever growing data. And now data is not just called data, now it's big data. Okay, even
Correct.
so for two, so we are all going to discuss actually all that stuff, but let me answer you the one that the query you asked. I'm anyway going to discuss all that. So big data, to counter that problem, the growing volume, those 5 V's of big data. So let's just focus on the volume part of it. So this Hadoop came into picture, right? So Hadoop was basically taken up from the Google file system white paper, technical white paper that they talked about the distributed file system stuff. So let me, if I just, so basically what they talked about was the data locality. What they
Okay.
said, that, okay, these are my computers. Okay, these are my computers, and I don't need supercomputers now. These will be my commodity hardwares. I mean, it means simple 32 GB RAM, 16 GB RAM, that kind of stuff. And my data will be residing here only. Data locality, that is local to the computing, which I will be processing. Okay, and this will be my distributed file system. So some data will be here, and that computing resource will be here. So if I have a very large file, petabytes or terabytes or whatever, so some data will be here. I'm talking about Hadoop. Okay, so some
Yeah.
data will be uh, some data. So what's happening? Sorry, I'm very bad with paint, guys. So some data will be here, some data will be here, some data will be here, and all that stuff. So this was an overview of Hadoop file system, and within that there will be computing resources. So there is no, I mean, this keeps growing, guys. This keeps growing. This is just a small example. So if I keep, so the purpose is important. If my purpose is the growing business and the growing insights, one day your on-premise, will give away, because the scaling up of the system, because obviously if data is growing, you need to keep scaling up. There's no scaling down that's going to happen ever with your growing data. So you keep scaling up, scaling up, scaling up. You will not be able to bear the cost at one point, and the kind of complexities, the kind of integrations with all that stuff, you will not be able to do. There will be a lot of costing involved going forward. There's no chance you can do that. So such kind of systems, and almost today day and age, every business is having to go through this kind of data insights stuff. So they have to do your analysis, data science, apply your machine learning algorithms on them, create models. That is only possible with the ever growing data. So that is a trade-off they have to do. Okay, so which particular part of system I can keep it as on-premise, which particular I can keep on cloud. They have to do a trade-off on that. But these big systems, which will go, they will have to go to cloud. There's no other chance. You cannot, you only tell me, can you do all this on-premise? Even Hadoop is getting replaced by Snowflake, Redshift, and so many stuff, so many other, big warehouses, Azure Synapses, BigQuery. Even they are migrating from Hadoop, leave the traditional databases. Okay, I will send a screenshot. What I had I read one article. I'll send that screenshot in the group. You can have a look. Even the Hadoop folks, they are migrating to big data warehouses, cloud data warehouses, and Snowflake is the most popular in today's market. So I hope that answers. There's no I mean, I don't know if security will be an issue or if that, other, of course, security is the most issue. And as you said, going down the line, the costing also doesn't, have a major difference once you have it on premise and whether you have it pay as you go. That also, at the end of the day, somewhat, balances out each other. But as the cloud competitors will grow, people will start giving you for cheap, and they will say, okay, that guy is charging you more, come to us, we'll give you for cheap. So as the competition increases, there also you will see a revolution, because I think Alibaba is right now giving for very cheap only. So once
Yeah.
that, because it's anyway a Chinese company, and they believe in, first giving things for cheap, and that's how they capture the market. So all those competitor stuff will happen there as far as the costing is concerned. And for this big organizations, most of the times they don't care about costings in these terms. Most of the times, they are mostly
No.
trying to save costs through automations, through reducing the workforces. That's what is always there in their mind most of the time. So
Yeah.
there's no chance. I mean, on premise, I'm sorry, it cannot handle today's business insights and data science stuff. It cannot handle that.
Okay.
So they will have to migrate. So okay, there could be systems where they feel, okay, I don't need to migrate it. It's a legacy system. It's so anyway going to go and get decommissioned down the line. So why to migrate it, let it be there. So there could be there. But as to answer your question, there's no chance that you cannot go to cloud now.
Okay. Okay. Clear, Abdullah.
Cool, no worries. So we are done with the topic, guys. I mean, we can have a discussion. I mean, you can ask your queries, and we can have even you can give your insights also. You can share your knowledge also with us if you want. We are done with the topic. So if anybody wants to drop off, feel free to drop off, and anybody wants to have some discussion, we can do that. Not a problem. Okay, guys. So please do watch the recording once again in case, and if you have any doubts, please feel free to ask me tomorrow. Tomorrow we will see the use case of Netflix, and then we will connect that to Snowflake, and we will start our journey of Snowflake. Okay, guys. So I'll take your leave now. Thank you so much, and have a good night, and see you tomorrow, guys.
Yeah. Thanks, Abdullah.
Thank
Thanks.
you.
Thanks, Abdul. Thanks, Abdul.
Thanks.